We started with hypothesis testing, an introduction last week, and we want to now look at the concept of what hypothesis testing is. Okay, so in class we said that there are two approaches to statistical inference. First method, just a minute. So we did mention that we have two main methods of going about statistical inference. The first technique is using estimations, okay, where we can use point estimators or interval estimators, okay, to find or to estimate the value of a population parameter, okay? Good. And the second approach is to make a claim, and then we test the claim using samples. And that is what we refer to as a hypothesis testing procedure, okay? Now, what is a hypothesis? A hypothesis is a claim about a certain population parameter. So, for example, the manufacturer of a voltic mineral bottled water, the big size, will say that I produce 1.5 liters of water. But then, as a researcher, you make a claim that is it really true that they are producing 1.5 liters of water? Okay, such a claim is a hypothesis. And the process of systematically checking whether this claim is true or false is what we refer to as a hypothesis testing. And we make use of samples. So you select a few samples from the population and take it through the rigorous testing, check whether the claim is true, whether they are producing 1.5 liters or not. Good. So a hypothesis testing is just a procedure which uses sample information or sample statistics to test a claim about the value of a given population parameter. Now, examples of such claims will be the manufacturer claims that its rechargeable batteries have an average life greater than 1,000 charges. So this battery could be Energizer or could be any type of battery at all. But they make a claim that at least when you purchase my battery, you have about 3 years warranty or about 1,000 charges on the battery. You usually see this on the phone batteries. They tell you, well, we have about 35,000 charges, which means you don't need to charge it per day. These are all claims. Another claim will be Pharma claims that its new malaria treatment will cure patients in less than 5 days. That is also a claim. But as to whether this claim is true or not requires a process of hypothesis testing, right? Good. Now, what are the steps in hypothesis testing? They are basically 5, okay? The first step is to make the claim. The claim can either be null or alternate, which is the opposite of the null, okay? Then we select a significance level, which will be used for testing. The next stage is to identify a test statistic suitable for such a test. Then the next step is to you formulate a decision rule, okay, based on your alpha level, select a sample, and then you arrive at your decision, okay, either through the critical values or the computation of the p-values. Then you decide whether to reject the claim, which is the null claim, or fail to reject the null claim, okay? So these are the basic steps involved in any hypothesis testing. Now, let's try and understand each of the steps one by one. When we talk about stating the hypothesis, what do we mean? It's I think about 3 steps. First, to convert the claim, okay, which is usually written in words. You have to convert it into a mathematical form, right? That's the first step. Then the second step is to check whether the statement is in the null form or in the alternate form, okay? Good, and assign them appropriately. Good. Now, let's go to the stage. So, the first thing we said, the manufacturer claims that its rechargeable batteries have a lifespan, okay? So it says have what? An average life greater than what? 1,000 charges. That is the claim, okay? So the first step is to write this in a mathematical form. And we all know that average is what? The average is just the mu, right? So it says the mean of all the batteries I produce. So it's a population mean, okay, is greater than. So greater than, we write the greater than notation. And he says it's greater than what? 1,000 charges, okay? So that is step one. Then in step two is to write the opposite statement to the claim, okay? And the opposite of greater than is not just less than, but less than or equal to, okay? So mean is less than or equal to what? 1,000 charges. Good. Then in the third step, which is identifying which one is a null and which one is an alternate. Good. The null hypothesis always comes with an equal to. So null hypothesis always move with what? Equal to. So you check the two statements, which one has an equal to in it. And of course, that is the second statement, okay? So if the second statement contains the equal to notation, that becomes what we refer to as a null hypothesis, okay? So we write it at H null, okay? So the null hypothesis, then you bring your column, okay, as you can see. Whereas the opposite statement will become what we refer to as your alternate hypothesis. Okay, so the opposite becomes the alternate hypothesis. So these are the process, the three steps, okay, in converting or in writing out your what? Your claim. Let's take another example. Okay. So we have the next example here. So Kinepharma claims that its new malaria treatment will cure patients in less than 5 days. So what is the claim? It claims that what? The new malaria treatment cures patients in what? Less than 5 days. So which means averagely, all persons who take their malaria treatment will recover in less than what? 5 days. That is what they are saying. Okay, so in 5 days. So that is a claim, okay? Then after writing in the mathematical form, we have to write the opposite statement. And that is going to be what? Mu is greater than or equal to what? 5 days. So that is the second step. Then the third step, we have to identify which one carries the equal to sign. And that will be this one, okay? So we assign that to H naught. So that is our null hypothesis. So H naught is this, whereas your alternate hypothesis is the claim, okay? Good. Now you have to take note. It's not always that you have the claim being an alternate hypothesis. Sometimes a claim can rather be the null hypothesis, okay? Good. So you take note of that. The next step is on how to select your significance level, okay? Good. And we have different significance levels. We usually refer to the significant level as the alpha level, okay, or as alpha. And what does it mean? First, we have to know that alpha is a probability, okay? Alpha is a probability, and it has to do with rejecting, okay? It has to do with rejecting a true, okay, a true null hypothesis. That is what it means. So alpha is a probability, has to do with rejecting of the true null hypothesis, okay? So in its fullest definition, we say the maximum allowable probability of rejecting what? A true null hypothesis. And such an error, you see, if the claim is true and you have rejected it during your tests, okay, the thing is 1.5 liters, but you concluded by saying it is not 1.5 liters. Then what you've done is you've committed a type 1 error, okay? And that is what we refer to as alpha, please. Okay, so alpha technically is the probability of committing a type 1 error. Now, in all our examples, okay, there are different type of alphas. We can have 10%, okay? We can have 5%, we can have 1%, okay? Good. But by default, okay, in most statistical softwares, we use 5%. So in other words, when you are not giving your alpha level in a question, just make the use of the default value, which is what, 5%. 5% simply means 5 over what? 100. 5 over 100 is what we all know, that is 0.05. Okay, good. So when you see alpha of 0.05, we mean 5%. That is what we are referring to. Okay, so let's move on. Yeah. Now, the next thing is deciding on our test statistic. Okay, there are different type of test statistics for various type of claims. Okay, so if the claim is about the population mean, if it's about mean, then we can either have the Z, okay, statistic, or we can have the T statistic. Okay, if it's about the variance, we can have chi-square, or we can even have F statistic, okay, for variation. If it's about proportion, we can have the binomial, or we can even have the set, okay, distribution. So depending on what claim is being made, the test statistics will differ, okay? But this morning, we are going to limit ourselves to a claim or claims regarding the population mean, okay? And for population mean, there are two types of tests which can be used. It's either the T statistic, or we are going to use the Z statistic. Okay. Now, so the question is, when do we use the sets and when do we use the T? Now, this is how the flow chart is like. The Z is used, or just a minute. Okay. So there are two conditions. Case one is if your population variance if the population variance is known or is given, when it's given, you have to use your Z statistic, okay? And you can see the Z statistic is just the observed mean minus the null mean over what? Your sigma over square root of n, which we saw in class last week. In class last week, we saw it as what? Z is equals to what? Is equals to mean minus what? X bar. Okay. Over, sorry.